back. So today we are going to talk about 2.4, the chain rule. So today we will be able to use the chain rule to take a derivative. So this is another way to help us take the derivative of a function. So let's first start off by defining what the chain rule is. So the chain rule is if h of x is equal to f of g of x, then the derivative is equal to the derivative of the outer function with the inner function still inside times the derivative of the inner function. So f prime of g of x times g prime of x. So let's go ahead and apply that rule. So y is equal to sine x squared is our first example here. So let's go ahead and identify what our outer and our inner function is. So outer and inner. Our outer function here, so our f of x, is the sine x is our outer function. And whatever's inside, kind of inside parentheses, is our inner function. So we have x squared as the inner function. And this is going to kind of help us so we can set up the chain rule up here. So our derivative for this is, we're first going to take the derivative of the outside, so the derivative of the outer, so the derivative of sine is cosine, and we're going to keep the inner function, so keep the inner, which is x squared, and then multiply by the derivative of the inner function. So the inner function here is x squared, so the derivative of x squared is 2x, and this is our derivative. We can simplify if we want to, or rearrange, I guess, to make it look a little nicer, and that is the derivative of sine x squared. Okay, let's move on to another example. So now we have cosine to the fourth x, and remember from yesterday we can rewrite cosine of x to the, I was thinking about what we did yesterday, to the fourth. So now we have our inner function of cosine x, and the outer is the x to the fourth. So once again, we're going to take our derivative. So we have f prime of x is equal to the derivative of the outer, so our outer is x to the fourth, so 4 times, and then leave the inner in there, and then subtract 1 from the exponent to get to the power 3, and now we're going to multiply by the derivative of the inner function, and the derivative of the inner function is negative sine x. Rearrange this to make it look a little nicer, and we get this. So negative 4 sine x cosine cubed x is our derivative for that one. Alright, example number 3, we have f of x is equal to x cubed plus 1, all cubed. So in this case, our inner function is that stuff in the parentheses, so x cubed plus 1, and the outer is the fact that it's being cubed. So we have x cubed, and just so you guys know, you don't have to write the outer and inner every single time, so you don't always have to write this. It's just here so we can organize our information a little bit better until we get the hang of all of this. So let's go ahead and take the derivative of this, f prime of x, excuse me. So the derivative of the outer is 3, keep the stuff inside, and then subtract 1 from the exponent, times the stuff on the inside, which is 3x squared, and that is the derivative for this one. So we can rearrange it if we feel like it. 9x squared, x cubed plus 1 all squared, and that's what that one will look like. sine of 2x all cubed. So now we have a function in a function in a function. So there's three functions here. So the way that you go about this is you work from the outside in and continue to take your derivative starting with the outer function first, right? So if our outer function here is the cubed function, then we're gonna take the derivative of the cubed and keep all the stuff inside the brackets and take that derivative. Then we're gonna multiply by the first inner function, the derivative of the first inner function. So the derivative of sine is cosine, and keep that other inner function there. And then we're gonna multiply by the last inner function, the derivative of that, which is 2. And that's how we're going to find the derivative of this whole function here. And we can simplify this. Let's see here. 3, we get 6 cosine 2x times sine 2x, squared. You can leave it like that. You can move it around if you want to. It doesn't matter. This is, they're both acceptable answers. I would multiply the 3 and the 2 to get things kind of more simplified, but this is acceptable. Alrighty, so this is our derivative. So this is here us doing the chain rule twice. So this is one where we did the chain rule twice. Okay, so let's look at another example, and here we have a quotient rule. So you can either do the quotient rule if you want to, but you would have to do the quotient rule and then do the chain rule as well, because you have this inner function and an outer function. So it's gonna get a little messy, or you can just move your stuff around, move everything around, and change it to negative exponents, and then once you get your derivative, change everything back to positive exponents. So g prime of t is now equal to the derivative of the outer, so we got to keep that -7 times -2 times the inner function times the derivative of the inner function, which is 2. So now we have -7 times -2 times 2, which is 28. Oh, I forgot to the -3rd power, I forgot my power. Times 2t minus 3 to the -3, and then we can put it back, like I said, in terms of positive exponents. So here is, our derivative. So it makes it so much easier. You don't have to use the quotient rule as well. Because even if you were to use the quotient rule, right, since your numerator here is a constant, when you take the derivative of a constant, right, you get 0. So it's just going to end up canceling out. But this just makes life a lot easier. Okay, let's do our last example, and we're going to find an equation of the tangent line to the graph of f of x equals 2 sine x plus cosine 2x at pi, 1. So the first thing we got to do is, whenever it says find the equation of the tangent line, you want to take the derivative. So the derivative of 2 sine x is just 2 cosine x. And this part we have to use, this part here we got to use a chain rule because we got cosine 2x. So plus cosine 2x, so negative sine 2x times 2, which is equal to 2 cosine x minus 2 sine 2x. Okay, so that's our derivative, and now we're going to use that derivative to help us find the slope at this point here at pi. So let's plug or substitute pi in for x. Loop. Okay, so now we have to evaluate evaluate this. So cosine pi is -1, so we have 2 times -1 minus 2 times, well, sine of 2 pi is also sine of 0, and sine of 0 is 0, so we have -2 for our slope. So plug that in into our point slope form, and y minus 1 from our point up here, so y minus 1 is equal to -2 times x minus pi, and you could totally leave it like that. You don't have to change it. This is an acceptable answer, and I'm okay with that as well. So if you do that on a test, I'm perfectly okay with this answer here, and I believe AP test is also. But if you wanted to simplify it and put it into slope-intercept form, you can very well do that. Doesn't matter to me. And I would leave it like that. I wouldn't even add these together. But so that is our equation to the tangent line of this graph at that point.